Alright, in this video I'm going to finish what I started. We were doing more with radicals and multiplication. So there's a few more examples. On number 11, we're now going to do, we're going to be using FOIL. We're going to be multiplying a binomial times a binomial. So square root of 5 plus square root of 6 times the square root of 5 minus the square root of 6. And so when we multiply the first terms, we get 5. When we multiply the outer terms, square root of 5 times square root of 6 is square root of 30. Now notice it's positive times negative. So it'll be minus square root of 30. The inner product is plus the square root of 30. And the last product, the square root of 6 times minus the square root of 6, will be minus 6. Remember, square root of 6 times square root of 6 is 6. So this just ends up being negative 1. Notice these add up to 0. In fact, we've discussed this before when we have this form where we have the same two terms. So each binomial has the same two terms, but one has plus in the middle and one has a minus. The inner and outer products are going to add up to 0. In fact, these are called conjugates, and anytime you multiply conjugates, this happens. The inner and outer product are going to be opposites. And so you can make things shorter by knowing that or remembering that. So on number 12, we have 4 minus the square root of 3 times 4 plus the square root of 3. So again, these are conjugates. When we multiply the 4's, we get 16. And when we multiply the last terms, we get square root of 3 times square root of 3. Of course, one's negative and one's positive, so it'll be minus. Remember, square root of 3 times square root of 3 is 3, and so this is just going to be 13. Now, if you're not comfortable taking that shortcut, you can do the inner and outer product, but again, those are going to add up to 0. You'll have 4 square roots of 3 and a minus 4 square roots of 3, and in fact, we have no radical terms. Number 13. Square root of x. I can't seem to get these radicals, make these radical signs very well. Let's see. Square root of x minus 2 times the square root of x minus 1. So go ahead and try that one. And then I'd like you to try this one, number 14. 3 plus the square root of 2. Quantity squared. Alright, let's see how you did. So these are not conjugates, so we're going to have to do all 4 products. Square root of x times square root of x is just going to be x. We've discussed this before. Basically, square root of x times square root of x is the square root of x squared. And again, these are opposites. When you take the square root of x and then do the opposite and square it, you get back to where you started, which is x. Square root of x times a minus 1 is minus square root of x. And a minus 2 square roots of x, that's going to go here. That's your inner product. And then negative 2 times negative 1 is plus 2. And so we're going to have x. And then minus 1 square root of x and minus 2 square roots of x. That's minus 3 square roots of x. We're just adding negative 1 and negative 2. And then don't forget the plus 2. Now, we've done problems like number 14 before, like if we had like x plus 4 quantity squared. And I always call this FOIL in disguise. We're going to need to write 3 plus the square root of 2 times 3 plus the square root of 2. This 2, this exponent, tells us to multiply 2 of these 3 plus square roots of 2. And so there is no shortcut that we can just use to go from here to the answer. We're going to have to FOIL this out. Notice also these aren't conjugates. They actually are exactly the same. So we'll have 4 products. So 3 times 3 is 9. 3 times the square root of 2. That's all I can do is write them next to each other. And we have another 3 times the square root of 2. And then the last product, square root of 2 times square root of 2. You should get 2 there. So notice the 9 and the 2 is 11. And you have 3 square roots of 2 and 3 square roots of 2 that's 6 square roots of 2. And so our final answer is 11 plus 6 square roots of 2. And again, you might be tempted to add the 11 with the 6, but this is a radical term, and this is not, so there's no way we can combine those together. All right, now we're completely done with that section.